Hello everyone, welcome to this continuation of the HCI IoT courses. In the first three courses, I introduced the overall IoT architecture and some popular IoT applications at the application layer, covered IoT trends in different industries, and described the Huawei IoT solution. We also learned about security problems faced by the IoT and about Huawei's solutions to these problems. Now, we will move on from the application layer to the network layer to take a look at common IoT communications technologies. In this course, I will introduce these technologies in general. In the following courses, I will explain NB-IoT and 5G technologies used in wireless scenarios, and I will go into detail on industrial and home gateways used in wired scenarios. What are the functions of communication technologies at the network layer? They function as a medium for connecting the sensing layer and the platform layer. As we mentioned before, communications technologies are the foundation of the IoT. If we treat the IoT as a logistics system, then communications technologies are different modes of transportation. For example, air, water, and land travel. Common communications technologies can be divided into two categories: wireless and wired. Wireless technologies can be further divided. For example, there are cellular networks used by operators and a series of short-range communications technologies like Bluetooth. We will talk about them in detail later. Upon completion of this course, you will have a general understanding of wired communications technologies, short-range wireless communication technologies, cellular mobile communications technologies, and low-power wide area, which is LPWA, communications technologies. Let's start with the wired communications technologies. First, let's talk about Ethernet. All of us are familiar with Ethernet. Basically, Ethernet is a type of network that we plug into our computer with a standard network cable. Ethernet is a main local area network, which is LAN technology of TCP/IP, and is the most common communication standards used in the current LAN. In the IoT field, Ethernet is widely used in industrial sectors and to provide wide access in a typical office environment. Thanks to its low cost, Ethernet has been used to create industrial Ethernet. Next, let's look at serial port communications, RS-232 and RS-485. If you have done embedded development before, then you are likely familiar with the RS-232. Does the port shown here look familiar? This port is found on the rear of legacy desktop computers. What are the characteristics of RS-232? RS-232 supports one-to-one communications over short distance. It is less than 20 meters. RS-485 is an upgraded version. RS-485 supports one-to-many transmission. Such a bus supports a maximum of 128 transceivers. The transmission rate and the communication distance are also greatly improved. In addition to RS-232 and RS-485, there is USB, which is used in serial port communications. USB, short for Universal Serial Bus, is used to connect external devices to computers. This bus is widely used in our daily lives. For example, the mouse, keyboard, printer, and mobile phone data cable are all use USB. This technology is also widely used in the IoT. There are four types of USB ports: Type A, Type B, Micro B, and Type C. The next is M-bus, which is short for meter bus. It is designed for remote metering and often used by electricity, water, and gas meters. This technology is not common in China, but it is widely used in Europe. What are the characteristics of M-Bus? M-Bus can power devices remotely without installing power cables. Meters using M-Bus won't be affected if you have a power outage at home. The last wireless technology we are going to talk about is power line communication, which is PLC. PLC transmits data on an electrical power cable. How does it work? First, high-frequency signals that carry information are loaded onto the current and transmitted through the wire. At the receiver end, an adapter separates the high-frequency signals from the current and sends the signals to a computer. PLC can be used only in near-end scenarios, where the voltage does not change, since high-frequency signals loaded onto the wire will disappear when the voltage on the wire changes. In metering scenarios, this technology is applied to data transmission from metering terminals to management terminals. Data is loaded on the cable and uploaded to the management terminals, which connect to base stations and upload the data to the database through switches and servers. In the subsequent process, power transformation and transmission are involved, where PLC is not applicable. This table lists and describes wired communications technologies. As you can see, most of the wired communications technologies are used in industrial sectors and public utilities. In the IoT field, movable devices account for a large proportion. Therefore, there are relatively few application scenarios for wired communications. More data is transmitted wirelessly.